The origin of particle physics. From when the concept of the atom was first proposed by Democritus around 400 BC to when sufficient evidence about the atom was provided by Dalton in his famous Dalton's atomic theory around early 800, the atom was believed to be the smallest indivisible particle of an element. But in 1897, J.J. Thomson discovered the electron. Later on, proton was discovered by Ernest Rutherford in 1919, and in 1932, James Chadwick discovered the neutron. So by 1932, it was already an established fact that the atom is made up of three subatomic particles: the electrons, the protons, and the neutrons. However, from this time, scientists believe that this could not be the end. There could be more. So many scientists went into research. The theories and the discoveries of thousands of physicists from early 1930 have resulted to remarkable insight into the fundamental structure of matter, and it is now known that the protons and the neutrons are actually made up of fundamental building blocks called quarks. Also, the electrons and two other similar particles to the electrons known as the muon and the tau, together with their associated neutrinos, form another group of elementary particles known as the leptons. The leptons and the quarks represent one of the two main categories of fundamental particles known as the fermions. By definition, fermions are subatomic particles that have half-integer spins and follow Fermi-Dirac statistics. The name fermion actually was obtained from the name of the scientist Fermi. We still have a lot to learn, and so we won't go on at this point to explain the meaning of half-integer spin and what Fermi-Dirac statistic is. This is just an introductory lesson. Spin, for example, is one of the lessons we're going to consider in detail in this course. Still from the theories of scientists since 1930, it is also an established fact that the interactions between the fundamental particles are made possible by other fundamental particles called bosons. Another name for bosons are force carriers. You can also call them mediators. The bosons are in two main categories. We have on one hand the gauge or vector boson, and on the other hand the scalar boson. The gauge bosons are four in number under the standard model. We have the photon, the gluon, the W bosons, and the Z boson. The photon is the mediator for the electromagnetic force, the gluon for the strong force, while the W and Z bosons are the mediators for the weak force. The electromagnetic force, the strong force, and the weak force are three of the four fundamental forces of nature. The fourth is gravity, and the mediator for gravitational force is the graviton. However, graviton as a force carrier for gravitational force is still hypothetical. It is only a theoretical treatment at this level. The standard model, which is a physics theory that explains how the basic building blocks of matter interact, does not include the theory of gravity. The scalar boson, on the other hand, is only a single boson, and is called the Higgs boson. Higgs boson is the quantum particle associated to the mass-given field known as Higgs field. Just as we define fermions, bosons are subatomic particles that have zero or integer spin and follow Bose-Einstein statistics. And you can see from here that the name boson comes from the name of the scientist Bose. The model put in place to study these building blocks of matter and how they interact through the three forces: that is electromagnetic force, weak force, and strong force, is called the Standard Model. So in summary, we can say that the fundamental particles can be divided into two main categories. On one hand, the fermions, which are matter particles, and on the other hand, the bosons, which are force carriers. The fermions are further divided into quarks and leptons. Each of these two categories, that means the quarks and the leptons, exists in 3 generations. Each generation contains 2 types of the particles, making a total of 6 quarks and 6 leptons. The bosons are also divided into 2 main groups, the scalar and the vector bosons. The scalar boson is the Higgs boson, and the vector bosons include the photon, the gluon, the W boson, and the Z boson. Again, the graviton, which is the mediator for gravitational force, is not yet included. Yeah, it is still hypothetical at the moment. The fundamental particles that we have just considered are the building blocks of the hadrons. Hadrons are composite subatomic particles. Hadrons are generally composed of 2 or 3 quarks held by strong forces. They can be divided into 2 main categories. We have on one hand the baryons, also known as composite fermions, because they have half-integer spin, just like the fermions we have considered. And as composites, each baryon is made up of 3 quarks. We have, on the other hand, the mesons, also known as composite bosons, because like the bosons, they have integer spin. Each meson consists of a quark and an antiquark. The baryons are further divided into nucleons and hyperons. The hyperons are many in number. We have examples like lambda 0, sigma, psi, omega, etc. And each hyperon have 3 quarks, just like the nucleons. But they are different from them in that each hyperon has at least 1 strange quarks. We've just talked about the quarks, and the quarks are 6 in numbers, and 1 of them is strange. They are also more massive than the protons and the neutrons, and they are also unstable, and so decays to lighter baryons and mesons. And the nucleons are divided into protons and neutrons. The protons are consisted of 2 up quarks and 1 down quark, while the neutrons has 2 down quarks and 1 up quarks. For the mesons, there are also many in numbers, but 2 of the most common ones are the pions and the kaons. Good. We've come to the end of our first lesson, Introduction. We've come to the end of it. Our next lesson, we'll be talking about the basics of nuclear physics, and our discussions will be centered around nuclei symbols, types of nuclei, and derivations of some units used in nuclear physics. This is done for the love of physics. Every week, I will be uploading 1 or 2 video lessons. If this particular lesson has been helpful to you, I would like that you like, share, subscribe, and click on the notification bell to know when the next lesson is available. This is Physics with Omia.